Hey everybody, so I wanted to look at another example of finding the function rule or writing the linear equation from a table. Earlier we were looking at some and we were using the slope pattern to find the y-intercept, but I wanted to show you an example of how to work this out when the numbers are kind of large to where using the slope pattern isn't really efficient. So let me show you an example of what I'm talking about. Okay, so here's the table. I just made this up, and I'm going to write the function rule for this linear function. Um, and we've talked about this before, that I'm always going to need to come up with y equals something x plus something, okay? This first blank, excuse me, this first blank represents the slope, okay? Now, graphically, that would be rise over run. But in the case where we have a table, we're going to do y change divided by x change, okay? Or the change in y over the change in x. So let's look at that. How are the y's changing? To get from 60 to 59, subtract 1. 59 to 58, subtract 1. 58 to 57, subtract 1. So my y's are changing by -1 each time. What about the x values? From 30 to 32, 32 to 34, 34 to 36. Each time, these are increasing by 2. So my x is changing by a +2. Okay, now, normally I would say type this in your calculator and reduce the fraction, but -1/2 is just -1/2, okay? I do not want decimals for slope. So I'm gonna just leave it as -1/2. So there's my slope. Now here's the problem. So we need the y-intercept, b, and whenever I'm looking at the table, I wanna look for the ordered pair 0, b, okay? My table doesn't have a 0 for an x value. Now I could use my slope pattern and count backwards. So instead of adding 2, I could go backwards by subtracting 2. And I could keep doing that pattern over and over and over and over until I got to 0. So it would look something like this. I could subtract 2 and I would have 28. I could subtract 2 and I would get 26. I could subtract 2 and I can get 24. And you can tell this is going to take a long time to work this all the way back to 0. Then in the y's, I could use my slope pattern to go backward. Instead of subtracting 1, I could add 1. That's supposed to be a 1. So I could get 61, 62, 63, right? And I could count backward. But that's going to take me a long time, and I don't really want to take the time to do that, okay? That's totally fine if you do, but I don't want to take the time and do that. So I'm going to show you another way that you could work this out. I'm still going to use y equals mx plus b, okay? But now I know what the m is. We found earlier that the m is -1/2. I don't know the b, and that's actually what I'm trying to find here. I'm trying to find the b. So it doesn't look like I have enough information, but actually, I also have values for x and y. I'm going to pick this first ordered pair 30, 60, just because these are nice numbers. So I'm going to write my ordered pair 30, 60 over here. So what actually is an ordered pair? An ordered pair is an x input and a y output. So I actually have numbers that I can plug in for x and y. My y is 60. My m was -1/2 times my x was 30 plus, we don't know, that's the b. Okay? And now I can solve this like an equation, or this is an equation. So 60 equals, now I can come over here and I can do -1/2 times my x value of 30. and I get negative 15 plus b. Okay, now if I were going to solve this, to move a negative 15 to the opposite side, we have to use the opposite operator. So I'm going to add 15 to both sides. That's going to cancel out, and I'll be left with 75 equals b. Okay, so if you were to use your slope pattern and you were to count this back, count this back, count this back over and over until you saw a 0 in the x, that would be the ordered pair 0, 75. So this here is the function rule that represents that table. Okay, I hope that that makes sense. I hope that that is helpful.